squaring the 2 in the denominator as well as the 1 inside the numerator. Sehr gut. Or as they say in Germany, sehr gut. 2. Okay, now we're going to go ahead and move on to our next lesson, which is scientific notation. I am going to pull out, don't look, magical dust, and I've just thrown it on all of you. What you now all are, everyone in this room is a scientist. Now, why did I do that? Because scientists work with math. Scientists work with really big numbers. Say, for instance, what you had to do is you had to figure out the velocity, meaning the speed at which an object is falling. And you're looking at an object that has a mass of 17.96421 grams, and it's falling from a height of 3,941.62 miles. And this thing over here is hiding or broken. Or somebody took it to school with them, and you haven't got one. So do you have to go ahead and say, ah! Or do you say, new problem? I can solve that real easy. Okay. The magic of lesson 210 lies in moving the decimal points. To where there's just one number to the left of the decimal point. Okay? I'm going to go 1.796421 times 10 to the first. All times, remember I said I just want one number to the left of the decimal point? I now go 3.94162 times 10 to the third.
Then I still have to do the...
I'm going to estimate. I'm going to round them. Take a look. I move this decimal point 3 places to have only one number to the left of the decimal. The number of places I move the decimal is equal to the number of, that I have inside of my power. Same thing over here. I moved it 1 place, so it's times 10 to the 1. What I can then do is I can then go ahead and round this off to 1.8 times 10 to the 1 times 3.9, or better yet, 4 times 10 to the third. And it's really easy multiplying 3 times 1.8. Correct? Or I can even just round 1.8 to 2. And 3 times 2 is 6. 6 times 10 to the 4th. Real simple. Instead of me just going directly below this and putting 1.796421 and multiply each one across, you don't have to do that if you know how to do scientific notation. When we work on scientific notation, we're going to begin with one of the easiest numbers to use, and that's with the number 10. So please, let's go ahead and take a look at what we have over here. Both of us, please take a look at the top chart. It gives us 8.7, right? It says 8.7 times 10 to the 1.
What are you looking at?
Page 130 in lesson 210. Remember, we moved from lesson 2.9 to 2.10. Right up here, look inside of this chart. We have 8.7 times 10 to the 1. And then what they do immediately afterwards is they say, well, what's 10 to the 1? 10 to the 1 is just 10. Why? Because 10 has 1 0. Our next one is 8.7 times 10 squared times 10 to the second. And then it says, immediately after the equal sign, that's the same as 8.7 times 100. Well, why times 100? Because 100 has 2 zeros, and what we're doing is we are squaring, or we're going ahead and multiplying it by 10 to the 2. We go to our third one. 8.7 times 10 to the third is going to go ahead and be 8.7 times what, Lauren? The one where that gray box should be. What should it go ahead and be? 8.7 times what? 10 to the third. What's another way of saying 10 to the third power?
30.
Let's take a look.
Oh, you mean like, so should I just do 10 times 10 times 10?
Yeah, what's another way of saying 10 to the third? Would that be equal to 30?
1,000?
Huh?
1,000?
Very good. Can you tell us why?
Because 10 times 10 times 10 is 1,000.
But no, it's another way of knowing it. This, 1, 2, 3 zeros. It's just going to be a 1 with 3 zeros. And then if we multiply it out, we go 8.7. Now I want to show you something really cool. Okay? Watch this. 8.7. I'm going to go 8.7 times 10 to the 5th. Wow, what's so amazing about this is I'm going to bring this down. Oh, 10 to the 5th is going to go ahead and mean a 1 with 5 zeros after it, correct? Which is 100,000. But watch what I'm going to do. See this 5? See this decimal point? Watch what I'm going to do. 1, 2, 3, 4, 5. $8.7 times 10 to the 5th is 870,000. When I have 10 as my base and a 5 as my exponent, my power, I go to where the decimal point is. And I move it the number of places the power or exponent tells me to move it. What about this? What if I just had a 9 times 10 to the 4th? There's no decimal point there, so what do I do?
Add a decimal point.
Good. Where would I add the decimal? Would I go like this, put it over here? Where would I do it? Where would I put it? Yeah. And why can I do that, Lauren?
Because the 9 is a whole number.
Yeah. In other words, it's a whole number without parts. But if I want to add parts, or if I want to add more zeros to it, I can. Rem, you watching? 10 to the 4th.